My email here is on the bottom and my Twitter handle. Feel free to contact me anytime. Today we're going to be talking about data modeling. In the last webinar 102, we talked about all the binary operations in the SDKs that you can utilize to create a model, setting up your SDK, etc. In this, we're going to talk about JSON and differences between relational databases and Couchbase, and talk about different key patterns and strategies you can use. Modern day application building involves quite a few different ideas and technologies. It's very different than in the 90s what building applications were like. And I think that one of the most challenging things about moving from relational systems is that we spent so much time in the relational world. It takes time and effort and practice to kind of reframe your mind and understand how to do it the NoSQL way. And it's actually quite liberating as well. So I like to start my developer talks with a little bit of history. So, for anyone who's familiar with philosophy or art, the modernists in the turn of the last century, I guess the previous century, then the last century, really thought of the world and the mind as like this gigantic puzzle, and all the pieces just fit together neatly. But actually, what the world looks like, and this is the postmodern mind, is everything is sort of interconnected and relative, much more complex than that simple puzzle. What our developer brain really looks like is more like this. We have all these different influences entering our mind. We have all these different services happening. There's all these different integrations, and integrating all these things together is a complex, reuse and creative use of different technologies merging together to create a unique application. I guess this would be kind of the postmodern mind, or the post-postmodern mind for philosophers, whether we're in that sort of post-postmodern world. With big data, you also have big scale, and so different strategies that were working before. So relational databases have been working for a really long time until the turn of the century, until the early 2000s, when big scale started happening and relational systems started failing to serve or solve the problems that were introduced by the creation of applications that can be used by millions of users, the increase of mobile and mobile broadband. Now everyone has more than one device. Applications can be connected to at any time. So it's not just it's not as simple as it was prior to the internet, where you understood the the sizes of your audiences. Everything was predictable. Now it's a little bit less predictable. There's virality. There's all kinds of new paradigms, all kinds of digital marketing schemes that create unpredictable sizes of audiences, and you never know. Like your little game on your iPhone that you just created might become the next big hit. So talking about sort of the differences in relational databases and Couchbase, as we all know, relational databases organize data as tables. Tables are made up of rows and columns, and every row has a specific schema, static type schema, and this does not vary from row to row. Simple data types are very easy to represent, of course, by just having a column, having strings or numbers or booleans, date times, etc. All those columns are very easy to represent in a single table. However, complex data types like dictionaries or hashes or arrays and lists or lists of dictionaries, etc., cannot actually be represented in a single table. Martin Fowler called this impedance mismatch, meaning our in-memory data structures don't match our data structures on disk. So with all rows having an identical schema, schema changes require taking the database offline, doing an alter, doing a migration, and it's a royal pain, and then bringing it back up. When you're developing your application initially, this may not be as big of a pain, although I still think it is. But when you have a live application running, this can be a real big pain for lots of reasons. One is that you make your application unavailable during this time when you need to alter tables and do migrations. So if offline, if users can't connect to your application, that means you're not making money. The other problem with it is that you have maybe internal political battles about you have to justify the addition of a column. It makes it so that it's much more difficult to make changes to an application, both politically and in terms of logistically. So also, reading and writing a transaction require mutex and locking within relational databases, which can be a performance problem, at larger scales. Couchbase operates like a key values store, a key value document store. Of course, we can also store all the simple data types that you would expect. We can also store binary as well. What's really interesting is that you can represent complex data types, in the JSON format. So JSON documents allow you to represent your object model more directly. So if you have an object model that has complex data types like dictionaries and hashes, or lists of dictionaries, or dictionaries with lists inside them, you can represent them very easily in JSON. JSON is basically a special class of string, right? Just like XML or HTML, those are just strings. And JSON is a special class of string that for representing data structures. So in Couchbase, the schema is unenforced by Couchbase itself. So it's implicit. Your application data model is what's determining the form of the data. But like say you have a collection of user documents, you have all these user documents, those documents can vary from document to document. That means that like if you have address 2 or address 3 for a particular user, or second phone number or third phone number, you might have documents that have address 2 and then other documents that do not, for those that just have a single address. So that can vary. In relational systems, for that same example, you'd have to decide whether to add these columns that are going to be mostly nulls, for instance. You'll have street address 1, and then street address 2, city 1, city 2, etc. And you have all these additional columns that for the most part may be unnecessary, except for in a few cases where people have second or third addresses. This gets really clumsy and cumbersome as well. The other thing that's excellent about Couchbase is that you can make these schema changes on the fly programmatically, dynamically. You don't have to take Couchbase down to change your JSON documents and change your implicit schema. This makes it very powerful for maintaining and keeping your application online, and actually doing very sophisticated things with your data model. So this is Martin Fowler is a famous writer and founder of ThoughtWorks, and this is how he talks about sort of the aggregate view of data. So you have this web form on the left. It's actually composed of all these different components, these different tables joined together into a single view. That's the aggregate view of this data. With relational systems, obviously, you have all these different tables. As data grows, this gets more complex. It's also more work to actually create this aggregate view. You've got more complex queries. You've got all these joins. Joins are expensive, and as your data tables grow in size, these joins get slower. For Couchbase, in general, more often, you're actually storing and retrieving that aggregate. It is a denormalized form of the data. So you had normalized your data model so that you have all these different tables, and then now you have a denormalized form of that data. So here is a document representing that same web form, and in this case we have all the information in a single document. What's great about this is that it makes it much easier to distribute that data. Denormalized data is much more easily spread across multiple servers because you don't need joins. That means you don't have to have them all exist on the same server. So joins pretty much require you to have all the different tables that you're joining together on the same server so it can compute the join. When you distribute those tables over multiple servers, those joins become even slower. It's just a physics problem. So this also, without the joins, it reduces latency as well. And having denormalized data, makes it so you can dynamically change schema and you have much more flexibility. So here's, furthering that, the theme we're talking about here. Here is a user class, and in this user class we have these simple data types and we have complex data types. And so ORMs are used often to make this a little bit easier for the programmer, but there is a trade-off with ORMs. The queries that you're going to be doing in relational systems with an ORM are much harder to optimize for speed. It's also slower to store and retrieve through ORMs. ORMs are not generally as performant as straight queries. So then you have to manually create all this stuff, which, is more time consuming and, a lot more work to change once if you want to change your data model in your application. Making these changes is much more complex. It takes much more time consuming. And then in the end, the performance is also not better. So that's the other note, is that it's more complex, it takes more time, and then you're not increasing your performance. For Couchbase, for these same things, obviously, with JSON, we can represent these complex data types really easily. So when you serialize your object to JSON and deserialize it back, you're getting these complex data types built into your document. In here, I have a little note that, right here I have this doc type. And I'm just mentioning this now because this is often something that we do. Some people call it class, some people call it doc type, some people call it type. In which case we're including with this JSON the object type that this JSON was serialized from. And I think that just as a quick note, this is a very common theme that comes up in MapReduce and MapReduce views and indexes. We often use these things, and so I'm just mentioning it really quickly, is that this object was serialized, it was a user object, and I also included that in the JSON. So one of the benefits of JSON, obviously, is that it can represent complex data and data structures. It's very simple, it's really easy to read. Almost all third-party services and integrations are now returning JSON, much more than XML. Facebook, Twitter, it's native to JavaScript, which can be really useful, and you can insert it straight into Couchbase. So if you do Facebook login on post authentication with Facebook, you're getting a whole bunch of JSON back. You can just store that straight in Couchbase. This makes your initial development extremely fast because creating a static schema for Facebook data is really, it can take you days and days because it's very involved. There's lots of different data. There's lots of lists and complex data types. So making all those tables and creating that schema can take days. Same with Twitter or other integrations. It can take days just to make your data model in your relational system. But in Couchbase, you can literally insert that JSON data directly into Couchbase, and you're off and running. And serialization and deserialization of JSON to objects is getting faster and faster. There's numbers of libraries in every language, and they're always improving them. So it's always getting faster because it is so common. So in Couchbase, we have what we call metadata, and we have the document value. So we have a key and a value. So the meta information is always kept in RAM. These are all the keys are unique within a bucket, and the sort of ID is the key, and then we have some other information, revision number and flags, and the expiration and the type. And then the value itself is the document, and that document can be a JSON document or just a simple data type. It doesn't have to be JSON. It can be also a simple data type. In this case, we have a JSON document, and all of the values that can fit in your configuration of your bucket, all the values that can fit in there will be kept in there. So, and the most recent ones will be kept in there. If you don't have enough, if you didn't configure enough RAM to have all your document values, and the least recently used or not recently used will be evicted as you create more data. So this is the general format. This is generally what you're doing almost all the time. So you're creating a user object here. You're serializing your object into JSON. You're storing it in Couchbase. In this case, we're creating, so we're adding it to Couchbase. Then, later you're retrieving that JSON back. You're deserializing back to your user object. So let's talk about a few basic key patterns, and these come up quite often. These are really useful patterns in Couchbase. They're pretty typical key value patterns. So first of all, you have to realize that there is no keying mechanism within Couchbase Server itself. So you're, as the application developer, creating the key structure. You're deciding what is going to be used for keys. Obviously, since it has to be unique within the bucket, things that are typically unique are what are more often used. So like an email address will be unique. Usernames can be unique. You know, SKUs or ISBN numbers are unique. And then you're creating a format. I typically, and a lot of developers typically prefix with, this is not strictly necessary, prefix with like sort of the type. So I say user : justdeep@couchbase.com. Some people ask why 2 colons. I just find it easier to read. You can do 1 colon, you can do nothing. You know, keys can be 255 characters of any, you know, it's a string, 255 characters, and it's up to you. They have to be unique, so I tend to pick unique things. You know, I don't pick social security numbers or credit card numbers or anything like that. I would shy away from that. So in this case, I picked, you know, justdeep@couchbase.com. I'm going to use email addresses. And then for products, I'm using the ISBN number. I could use the SKU. So with predictable keys, what I mean by a predictable key is that if I have a login form and in my application you're logging with your email address and you're hitting login, the login button, I now know your email address. So I can look up your email address, you know, as a key you know, for my document, and if it exists, I know that you exist as a user. If it doesn't exist, then I know that I need to say, oh, you're not registered, because I'm using the email address as a key, and I'm getting that information from the login form. Likewise, in the sign-up form, I can check to see if that email address has been registered because the key is also the email address. So that's what I call a predictable key. Unpredictable keys means that you're using some sort of randomly generated key, like a GUID or UUID or Twitter Snowflake or some other mechanism for generating a key that is not predictable. When the user logs in with their email address, it doesn't necessarily map to that UUID. So it's not a predictable key from the email address. Now I could hash their email address and use that. That's another way. If I don't want to actually use their actual email address as the key, I could hash it or do some other sort of transformation so that it's still predictable, meaning I'm deriving it from the email address. And if you use a random ID and you don't use a key pattern, which I'm going to describe, you're going to need to use views and indexes to find those documents because you cannot figure out what the key is just from the information you retrieve from the user. So let's talk about what counter ID pattern. In this pattern, I'm using an atomic counter, and in this key, I just called it counter key, is the key of the atomic counter. And from that, when I do an increment, I'm getting a new ID. And I'm using that ID as a component of the key for the actual data. So in this case, I'm adding a user, and the ID, I'm doing an increment on user count, and then I'm adding user and let's just say the count was 5, user 5, and the user data. So I'm using a counter and the actual data, but the counter value is a component of the key for the actual data. This also allows me to iterate through this collection without a MapReduce index because I know the total count of the number of, let's just say, users. So if I just do a retrieve on that counter key, I have the current count, and I can iterate through multi-gets. Maybe I can do 10 at a time or 20 at a time, or I can just iterate through and do some sort of cron job. So with this scenario with a counter ID, I actually know the size of the collection because I'm only doing increments and when I create new data, and so I have the total count of the number of items within this collection. It's similar to an identity column in the RDBMS, and then you're basically creating a pair of operations. I'm incrementing and then adding, incrementing and then adding. And so that atomic counter is sort of the foundation of that. And then using the value that I retrieve after increment is the component of the add on this. So then we also have a lookup pattern. Lookup pattern is basically finding multiple ways to get to a single document. So let's just say I'm using some sort of ID system. So I add this user and I add the user data to Couchbase. This is an unpredictable key. But what I'm also doing is taking the email address, and the value is the actual ID of the primary document. So I have what's called a lookup now. I can look up the primary document by the email address by creating another document whose value is only the key of the primary document. And I can also add another one. So let's just say I do a username as well, and its value is only the key of the primary document. Now I have two different ways to get to that unpredictable key of the primary document. I can do it through email address, and I can do it through a username. For retrieval, it's basically a two-step process. I do a get on that lookup document, and then take that key and do a get on the key to get the primary document. And no matter how many lookups I have, I can always get it two different ways. And it's always a two-step process. I get the primary document key, and then I get that actual document back. So this makes it really easy to have multiple ways to get to a document without a MapReduce index. And this is basically a key pattern, a key value pattern that you can use to make it so that you're only using binary operations, the fastest operations in Couchbase, to get to particular documents. For certain things, I actually do recommend using these patterns. One of them is users, because users tend to be the highest volume within your your data store, and also having that sort of consistency, with that makes it really fast to do, user registrations, etc. So you're not relying on looking up a user, through a MapReduce with its eventual consistency. You have immediate consistency while using these binary operations, and of course, binary operations are, consistent in Couchbase, immediately consistent. You can read your own writes. So it also scales really well because you already know how many operations it's going to take to get to a document. When you have 100,000 or 200,000 or 300,000 users, it doesn't get any slower. It's actually very consistent performance, across, as you grow your user data set, you get consistent performance. While in relational systems, that actual lookup will get slower and slower because the table is getting bigger and bigger. And if you compound the problem with joins, it's going to get slower and even slower faster because joins are very expensive. So the lookup pattern can, obviously you can have, 10 different ways to look up the same primary document. So on the right-hand side, I have Facebook ID, Netflix ID, Twitter ID. I have multiple email addresses, and I have a username. In this case, I'm actually using a counter ID pattern with a lookup pattern. So I'm using a counter ID to generate the user ID, and then I'm also using a lookup pattern to point to that primary document. So in this case, I have lots of different documents that actually point to the primary document. So you could say, so this is a sort of description or visualization of it. This is how I'm going to create using both the patterns together. The ID is an increment on user count. I'm using that user count to add the primary document. Then I'm adding, lookup documents, which just store the ID itself. And data retrieval is, again, two-step process. Do a get on the lookup document, and then get the primary document. So the pros of this is that you can, use only binary operations, sub-millisecond, and overall it's much faster than having a huge volume of view queries. Because there's, over-the-wire binary operations. These things are super fast. You also get around the view index problem because you actually have, different ways to get to a document, and I think that that's also very useful. It's always consistent. The binary operations are consistent. Couchbase is a consistent database. You can read your own writes, so it's always consistent when you use the key value patterns. One of the cons is that you're increasing the number of documents within Couchbase. With all these lookup documents, you're increasing, the number of documents, per user, and also increasing the metadata requirements, in RAM, etc. So, for the most part, most people, it's a non-issue because they configure their cluster with enough RAM to handle, tons of metadata. Metadata is basically, I think, 56 bytes plus the length of the key. It's not huge. And generally it's a non-issue, and I think for certain things like fast user creation, etc. I think that this is actually, the way to go. So in this case, on the left-hand side, you have this, user table with this information. On the right-hand side, you have, a counter ID, you have a primary document, Facebook ID, and Facebook ID lookup, and email address lookup. So these are kind of how the two look between each other. So, when you're doing these inserts and you're doing these retrievals, as these tables grow on the left-hand side here, you're inserting into users, and then you're doing these gets. As the data grows, this actually gets slower and slower. The way it's just through the nature, and this is without any joins, right? This is without any joins. This is going to get slower and slower as it grows, for each request. While on this case, on the right-hand side with Couchbase, here's a user document. I'm doing these operations that are extraordinarily fast, and then when I'm doing these gets, it's 2 gets and some millisecond, and even if the data grows, it doesn't get slower and slower. It has linear performance, so it stays the same. So there is also times where you want to use multiple documents. I talked about the lookup pattern, but there's also other reasons to use multiple documents within Couchbase. In this case, on the left-hand side, I have this, this single user document that has all kinds of information in it. All my shopping carts, all the different products I've bought, all the games I've won, all the different notifications. And in this case, I might want to have sort of, a different scheme where I'm using the user, the user key as sort of a base key for additional documents that are also predictable. So in this case, I might have, on the right-hand side here, this is my primary document, let's just say, and then I have, the points as a separate document. I have shopping carts and the product spot as its own document. Games won. I have a notification count using a counter ID pattern, and all the different notifications are here. Here's number 56 and number 57, all the latest notification. I could have another count for which notifications I've viewed, and then only show the difference in notifications between the last time I was on the site or been notified and this time. I can look at the difference in the 2 counts to keep track of that. So this is a sort of a way of having multiple documents, representing different user behaviors, so that in the case of a single user, you probably won't have any race conditions, because all this is just a single user, and users tend to be able to only do one thing at a time. But what if these were sort of a comments on a particular blog, for instance? If all the comments are in a single document, then I might have a race condition if I'm super popular, and like I'm Michael Arrington just wrote a blog post, he gets lots of comments really quickly. There might be a race condition if it's all in one document, and I could use CAS, and also that document could get bloated, meaning I have so many comments in that one document that document just gets really large and bloated. Instead, I could use multiple documents. I could use a counter ID pattern for the comments, since the people that are going to be viewing that blog and viewing the comments will probably be looking at those comments only 10 at a time. So I can use that sort of counter ID pattern and just pull 10 comments at a time, like most recent first. So that's one use of the pattern. So in behavior-driven design, you're reducing the number of user actions that can affect a single document. This reduces the conditions of race conditions that can happen on a single document, and then you can use compare and swap even in those cases, so that you can avoid race conditions and use optimistic concurrency to kind of handle them. User actions or user behaviors affecting a single document, you can separate that user document and using a predictable key suffix structure based on that user document, etc., to make it accessible and modifiable via getters and setters in your sort of class. So this encourages you to do simpler, smaller methods that are easier to write and maintain also. If you have these separate documents, it can also make your TDD, BDD easier to maintain. So let me take a little break and answer some questions.
Thank you, Jasdeep. We have a lot of questions coming in, so those that we are not able to answer during the session, Jasdeep has a blog where he answers all the questions after a day or two, so we can send the link on the follow-up email. So the first question is, so how do you handle updates of data? Won't it be very time-consuming? That's back from the initial part of the presentation.
I'm assuming that you're actually talking about changing a schema or migrating from one document structure to another, because just doing a replace operation is not a big deal. It's sub-millisecond as well. So I'm assuming you want to modify your document structure from one to another, and this is a pretty common question. In that case, there's two different ways of doing it. One is that within your application model, you actually have sort of a data transformation method within your object, so that let's just say your state one is version 1 of this object, and then you are making a modification. Let's call that version 2. You can actually, and Zynga did this quite a bit, and a lot of people do this. You can actually track the version also within your document. So if you're basically saying object version 1, and then you're inserting the version number into the document itself. And so when you retrieve that document, it's version 1, and you need to execute this sort of transition to version 2, some sort of code to add values. You don't always have to do that, though. I mean, if you're adding new JSON keys, it's really a non-issue, because, yes, the old keys are still there, but it doesn't really matter. You don't have to necessarily delete them. You can leave them. And I'm going to show a little bit of that in this modeling a user. The other scenario is actually, yes, you iterate through and do a cron job, where you modify all the documents and and you can create a MapReduce index to have a collection, or if you're using a counter ID pattern, you can iterate through the collection and modify them all if that's important. So you can either do it on demand, when like a user document is retrieved, that it needs to be transformed, and you transform it right then, or you can do run some sort of job where you iterate through and do that transformation. It's no different than doing a migration, with relational systems, is that you actually have to migrate. But in Couchbase, you can migrate it on demand, where you're changing the structure as you retrieve the documents, or if it's important that all of them are transformed at the same time, you can run a job. But you still, in both cases, you don't have to take Couchbase Server down to do it.
Perfect, thank you. Another question, you talked about the performance of Couchbase being linear. Isn't the performance of a relational database, wouldn't an index for the relational database give you also a linear performance?
No, it doesn't. Not as the data set gets larger, because you're also, if you have no joins, then yes, up to a certain point, because you will vertically scale your relational system as your data grows, but then it will hit a cliff, and that's where you have to figure out how, because you have to vertically scale your relational system. As long as you've denormalized your data within your relation system so that you actually have no joins, then yes, the answer is yes. As long as you can continue to vertically scale that server. Basically, the ideas of NoSQL came from the early 2000s, and what happens when you have to scale a relational database vertically, and once you hit the ceiling of how vertical you can go. Once you've hit that ceiling of verticality, you actually have to do things that are like denormalize your data. You have to get rid of joins. So if you've already denormalized your data, you might as well switch to Couchbase, because you're going to get much higher performance because it's coming out of RAM. So there's really no point of having a relational database at that point.
Thank you. One last question before we continue. So in the last slide before the break, how is this actually representing actual data stores? I assume all those variations are in a single user data store or document.
So on the left-hand side, we have a single document for everything. I'm assuming he's talking about this slide, yes. He or she. So in this case, I have a single JSON document representing the entire object. On the right-hand side, I've split up it into multiple documents. I guess the question is, how would you do that? There's different ways of accomplishing that. in Ruby, I actually customized my getter and setter methods so that when I get shopping carts, I actually do a Couchbase get on the shopping cart document that's keyed based on the user ID, or the user document. So it's
Yes,
user. Does that make sense?
the right side of the slide is the object of the question.
Yes. Well, what's the question then? How do you do it?
Yeah, how is this actually represented in an actual data store or document?
Well, these are all individual documents. So these are all separate documents on the right-hand side. So this is one document, this is another document, this is another document. I guess I don't understand the question.
Yeah, that was the question. If it was multiple documents, basically,
Yes,
just
yes,
one
yes.
data store.
Yeah, so on the left-hand side, it's a single document with everything in it. On the right-hand side, I have multiple documents that are using the user key as the sort of base, and then I add a suffix for those documents. So these are each individual documents on the right-hand side.
Thank you.
Cool.
We can continue the presentation. We'll have more time at the end to answer these additional questions.
This session always generates lots of questions. So let me make sure I get through everything as well. So modeling a user. This is one important thing that I like to talk about. That data is data, regardless of the form it takes on in the database. Meaning, you're storing the same data, whether it's in a relational system or Couchbase, you're storing the same data. The data is still the data. It's generated from your objects. It doesn't really matter what the form is. If you get over the form, then and learn how to use different forms, it's very useful. So the NoSQL paradigm shift is structural. It's not the data itself. So you're still storing the same data. And I like to say that objects don't care how their data is stored. You're decoupling that from your objects. And your application model has its own object model, its own relationships. So this is kind of a helpful tip to kind of move from a relational system to Couchbase NoSQL document base, is that data is data no matter how it's stored, and if you can decouple that in your mind and learn how to use more denormalized forms of data, it's very cool and awesome. It's awesome, and you can develop applications so much faster. So here we have that user class again, and on the right here's like a representation. Here we have to create this table on the right hand side that represents the user. All simple data types here. So in Couchbase, this looks like this, right? This is a user document. I'm using the email address as the key, and this is the JSON representation of that same object. Now I'm going to add a few things. It turns out I don't want to just use name. I want to use first name and last name, and I want to have an updated at, right? Because every time something changes, I want, I want to actually record the time in which it was, modified. So now what I have to do is, I have to take the database offline in relational, execute the change in migration, and bring it back online. In Couchbase, I actually don't really have to do anything except modify my object to store that information. Now, when, like the question that was asked, when I retrieve that user, I'm going to say, oh, I don't have a first name and last name yet. I'm going to do a split on the space, in the name and generate the first name, last name, and store it. But I don't have to, take Couchbase Couchbase offline to do this, right? And then I also add an updated at field. In this case, I'm using epic time, but I'm adding, a few more fields. So now I want to add, something a little bit more complex. I have an array list that I want to add, and that's just my favorite colors. In this case, I actually know that I'm not going to have a billion favorite colors. I may only have 2 or 3, So I'm going to take the database offline, execute the change in migration, bring it back online. I'm adding favorite colors. But because this is an array list, I'm going to have some sort of special processing in my model to encode and decode to and from an array list. I might have to write that, or if I'm using the ORM, it might handle it for me. But it's a little bit more, complex. Couchbase, again, really simple. Oops, I forgot to make it blue, but I got favorite colors right here, down below. And because JSON can represent these types, really easily, my sorry, I hate when I hit next by accident. My favorite colors there are easily, transcoded to and from JSON by my JSON transcoder. Now I'm going to add something a little bit more complex. Here I've got, another array list, and that's the products viewed. Now, because it's, could be, a large list, I don't necessarily want to make all these different columns in my relational database, or have a column that is just a list, because that list, a text-based list, because that list will grow, and then I have to do another query with another join. And so in this case, I actually just go ahead and make a normalized form. I create a new table called products view. I have two foreign keys. I have the UID and the product ID, and then there's my retrieve. It requires two joins to get the the list of products viewed. So again, in order to do this, I have to take it offline, execute the change, and bring it back online. With Couchbase, I have two different ways of doing it. In this case, I have a denormalized form where it's in that user document, and I can also, like I described the patterns, use a key value pattern instead, or a counter ID pattern for the products viewed if I expect it to be really large. But this is another way of doing it, and then I'll show you a sort of a visualization of how that works after I talk about the user ID for a minute. I have a visualization of that scenario. So I'm going to have to hurry to make sure I have enough time for extra questions. So what about the user ID? This comes up a lot. It's like, oh, in Couchbase, you don't have a way of creating IDs. So like, well, yes. So this is completely in the control and allows for creativity as well, in complete control of the programmer developing this. So in this case, I'm using the beginning here. I'm talking about using an email address or a username as the key. And then I'm getting the user doc based on that key. Or I'm using a counter ID pattern where I'm incrementing a count, and then I'm using that count for the user doc. And then I create a lookup, for the email address that points to that, counter ID, and then gets the user doc. Or I use a UUID or GUID or Snowflake or some custom mechanism where I, have a lookup that, points to that ID, and then when I want to retrieve it, I retrieve it based on that ID, that I get from the lookup. I can also use social login. So if I'm only using Facebook, just one social login, I don't need a lookup. When I get the authentication from Facebook, the post authentication, I have their Facebook ID, and I can just store that directly, user or U::, and the Facebook ID. And then when I want to get the user, when they re-authenticate with Facebook, I've got their Facebook ID, so I can do a get on that key and no problem. If I want to also have a lookup, with a Facebook ID, again, I create a lookup document, so that I can log in with email or Facebook. In this case, I have, an email address that points to the Facebook ID, the Facebook user or U::, and the Facebook ID is the primary document, so I can get that. You can see a pattern here. If I'm using a lookup, I have two different ways to get to the same document. The primary document, I can either use a counter ID or a UUID, or I can use a Facebook ID, anything that's unique. And that last example here is, using a custom with multiple lookups. I can do, email address points to the primary document. I can say the Facebook ID points to the primary document, and then the primary document is the user document. So I have two different ways to get to that user document. And, obviously it's a two-step process. Whenever you use lookup, it's a two-step process. So what about views or index to get a user document keys? It's not really, I don't recommend it in isolation, meaning because indexes are eventually consistent, and you can watch the webinar, Couchbase 104 coming up on Thursday to, learn more about it. I don't recommend it because it's eventually consistent, and a lot of people who are new to Couchbase were using this because they think of views as sort of SQL-like, it seems comfortable in some ways, but then they create a user and it hasn't gotten into the index yet, and when they query the index, they're like, hey, my user's not there yet. So if you want that consistency, immediate consistency, use the binary key value patterns. It also, for a high volume of data, it's going to remain, the same level of performance, the same speed, no matter how much data you have. And so that's also a benefit, especially with user creation and retrieval. However, you can also use the views and index on top of a key value pattern if you need alternate ways to get to a user document, like lookup by, some other thing like, multiple email addresses or zip code or some combination in case a user has forgotten their passwords, or for customer support. You can actually still have indexes on these documents. So you can use both key value patterns and indexes, but the key value patterns are what you're using primarily for, your application to make it super fast to create and retrieve users. So this is kind of how it looks, within Couchbase. We've got, the user document is going to be an email address. So first I'm getting the user document based on that email address, and I'm retrieving it. And I also want to get the products viewed. So it's a two-step process here. First, I get the user document. It happens to have the products viewed within that document. And then I'm doing a multi-get to get all the products at once, right? Because I generate a list of keys of all the products viewed, and then I do a multi-get to get all the product documents. This is pretty common sort of scheme here, is get and multi-get. Now, what if I actually have a counter ID, lookup, and email? So in this case, first I'm getting the user document ID based on the email address. What I get back is the number 505. Now I use that to do a get on the user document. And the key is U::505, and that gets the primary user document. And then I'm doing a multi-get on all those products viewed. So it was a two-step process to get the user primary document, and then I did a multi-get to get all the product documents. So the most common adjustments that happen, and this happened to me too when I was first learning Couchbase, a few years ago. I moved from I had an application that we were building in a startup, and we were using a relational database. We were trying to do a lot of real-time stuff, and even at smaller volume, we could notice the latency problems because these joins were just too complex, and we were inserting data too fast. Intuitively, with relational databases, we know it's costly to tie up the connection pool and overload with too many joins, so we try and avoid the database as much as possible. And even with caching, if you can cache, because there are certain situations with real-time stuff that you actually can't cache at all. You know that SQL is going to get bogged down by too many, complex joins and huge indexes. Even with all the optimizations, relational databases have improved considerably over the last decade since the early days of the internet, but you're still going to run into these problems. And I help a lot of companies all the time with their modeling, and when they're migrating from relational databases, some of these queries that they're trying to get around are just huge and so slow as a result. Those joins have to happen in memory, and it's really, you have to load all the different tables off disk, and it just, when you're doing repeated queries over and over with large joins, you're going to have lots of problems. So in Couchbase, these get and set operations, the storage and retriever are sub-millisecond, and they're trivial, so they're not bottlenecks. So you shouldn't avoid, you want to make one trip to the database, right? Because you're used to relational systems. But in Couchbase, doing multiple gets, is not, a non-issue. It's extraordinarily fast, and so you can feel comfortable doing them. And it took me a little while to actually feel comfortable doing them after working with relational for so long. The other thing is that your key design can actually be quite creative. You have different ways of creating keys that can make it so that you can have bits of information within the key itself, that can be useful. So understanding how to create your keys is sort of a skill in itself. And of course I gave you some simple examples, but you can come up with more complex examples, like if I have sort of a notification queue. Where I want to do notifications in the future, I can use a particular date and time as a document key, and then in that document is all the notifications I need to send out at that time. Maybe I have one document per minute, and as soon as it's done, it deletes the document. It sets a TTL, expiration on that document, or I can take it and do something else with it, or archive it or somewhere else, or something like that. So then I have this sort of worker queue that's actually looking at documents once per minute and sending out notifications. So that was a creative use of a key, where I use the sort of timestamp of a future notification list where I have these workers, pulling the document once per minute and, sending out email or push notifications or whatever. A lot of newcomers sees views as a replacement for key design because it's sort of SQL-like. You can query an index and you're like, well, I'll just use that. But actually, if you can use creative keying, and key design, you're going to have higher performance. But there's still plenty of things you cannot do with key design, in which case you're going to use, indexes and MapReduce or Elasticsearch integration. So relational to Couchbase, here on the left-hand side, I have like this, again, this simple, same example. I have this, shopping cart example where I have these cart items that have product IDs, and then I have shopping carts, that contain cart items, and then I have users that have shopping carts, and then in this case, this is my select statement for getting all the products in a particular shopping cart, and as for a particular user, right? So as this, grows, it's just going to get more and more expensive. It's, you can see all these joins and stuff, all this computation that needs to happen. On the right-hand side, I have these shopping carts that I'm using some sort of counter ID pattern, and I have all these cart items. I can do a, CB get on that document, get that list of cart items, and then I can do, iterative get, or I can do a multi-get on the cart items, and the performance is going to remain constant, because as my data grows, I actually have a sort of finite list of operations that I need to do, and they're all sub-millisecond. They should be coming from RAM if you configure your server well, properly, and you're just going to find that this performance is just going to be much higher than these tables that just keep growing and growing. Once you have popularity, these joins are going to be your nemesis. So, okay, so I tried to leave enough time to answer a bunch of questions. So, Franco, do we have some questions that I can answer before the end here?
Yes, thank you, Josdeep. We actually have a lot of questions.
So of course.
We're going to only cover a few, but again, yes. Josdeep will answer offline all of the questions that are coming in.
Yeah, I promise you I will, every question that's been asked, I'll give a detailed answer. I'll write a blog post with every question that was asked.
Perfect. So a question from Matthew. The main purpose of normalization is to avoid update anomalies. Since all programs have bugs, is there a way in Couchbase to prevent these update anomalies and not have to depend on the developer getting it right?
Now, so that's interesting, because actually the reason why you have transactions in relational systems is because of normalization. When you have normalization, you're splitting your data into so many different tables that if you don't update them all at once, your data integrity gets destroyed so quickly, because if you update one table and not the others, you have a problem. It's actually normalization that created the need for transactions. But when your data is denormalized much more often, as is in the case of Couchbase, yes, we can do single document transactions, of course. Multiple document transactions is a little bit more complex because you'll have to do what's called a two-phase commit. But it tends to not be an issue as much as it is in relational systems. It is really because of that normalization that you need transactions. And you can actually, if you want to read more about it, Martin Fowler's book on NoSQL Distilled is a really excellent primer as to what happened and why relational systems, needed, why all these NoSQLs came out and what was happening with relational systems and why, you have these transactions. Transactions are far less common or necessary in a denormalized data store, but you can obviously do, transactions on a single document, and then you'll need a two-phase commit, which we have a blog post example of two-phase commit as well, that you can use for multiple document sort of transaction management.
Great, thank you. We have another long question from Michael. So yeah. Is there a way to grab multiple documents for different IDs? For example, if I have a list of Facebook user IDs and I want to map to their user documents, is there a way I can pass multiple Facebook IDs and get back an array of documents?
Yes, that's the multi-get operation. If you have all the IDs that you want to generate keys for, or if you're just using the Facebook ID as the keys, then yes, you can do a multi-get operation, and all our SDKs support multi-get. where, because your data is distributed, multi-get can be a little bit faster. Now, our gets are so fast that we're talking about just a teeny bit faster here, where it actually distributes the queries to all the different nodes that have all the different keys and values at the same time, and then retrieves them back. You might see a slight performance increase, but again, because our get operations are also so fast, it's only slight.
Perfect, thank you. So a question from Chris. How would you do a reverse index map reduce?
Well, we're not actually talking about MapReduce. We can talk about that. I would love for you to join the next webinar, and we can talk about that. That's a little bit more involved question, but I can answer that in my blog post for you.
Perfect, thank you. And again, on Thursday we will have a whole webinar on MapReduce and indexing.
Yeah, that question is just a little bit more involved to answer, but I will answer that for you in my blog post because it'll take a while.
Another question is, are views the only way you can use compound keys?
Say that again?
Are views the only way you can use compound keys?
Well, keys are just a string, so you can use a compound key. It's your own creativity. I'm assuming you mean that you're using sort of like an array notation for the key. Because it's just a string, it's not actually an array. It's just a string, but you could have multiple components put together to generate your key and use that. And then you can use the key in your views, in your index, map function to break apart the key. So you can use that creatively. Because you get the key in your map function, you can break apart the key if you're using some sort of delimiter or something like that. You can break apart the key and index parts of it if you need to.
Thank you. We have time for a last question. I think this was for the beginning of the presentation.
Yeah.
So, will it not be advantageous to combine the counter ID partner with the lookup pattern?
What are some of the advantages?
If it would be advantageous or not.
Well, okay, so if you use them both together, you get two things. So if you use a UUID and lookup, one of the things that you don't know is the total number of documents, like the total number of users, for instance. If you use a counter ID and a lookup together, you get both. So you get the total number of users that you've created, and also you get this lookup pattern together. So if you use a UUID or a random ID, you don't get that total count. So that's the advantage. If you want to iterate through that collection, you use a combination of the counter ID and the lookup ID and the lookup pattern.
Perfect. Thank you, Steve. So we are out of time for today, but again, tomorrow we will send a link to the recorded version, the slides, and also the link to the Just Deep blog where you can read the answer to the questions asked during the session. Thank you all for attending the webinar today. I hope to see you again on Thursday for our session on indexing and MapReduce. And thank you again. Thank you, Just Deep, and see you on Thursday.
Thank you.